Welcome to 5.4. I will be able to apply double angle and half angle identities to find exact answers or prove trig expressions. Okay, so our first double angle identity, sine of 2 times theta. So this is the same as sine of theta plus theta. Well, we know what to do when we have something plus something. That's going to be the sum formula. So the sine, cosine, cosine, sine. So sine, cosine, cosine, sine. And then sine same. So we're going to put a plus in here, and then we can just fill in. Well, our angles are going to be the same on all of these. Theta for each. Well, sine times cosine is the same as cosine times sine. So we can add these together because these are like terms. So we get 2 cosine theta sine theta, or 2 sine theta cosine theta, same difference. All right, that's our first identity. Now with cosine, well, this is the same as cosine of theta plus theta. So cosine, cosine, sine, sine. And then for this one, we have the opposite sign, so we'll have minus here. Fill in our angles. And then let's see how we can simplify this. Well, cosine times cosine is just cosine squared. So cosine squared theta minus sine squared theta. Okay, box that one in, and I'm going to be doing lots of pausing in this video to write stuff down, and I want you to pause and get it down as well, and then rejoin me. All right, so for the cosine double angle one, we're actually going to have 3 options here, because you can see that cosine squared, well, I could replace that with something. I can take cosine squared theta and just plug in 1 minus sine squared theta, and then I can combine my like terms here, and I get 1 minus 2 sine squared theta. Then I can do the same thing over here. I can take out the sine squared and put in 1 minus cosine squared theta. And this time I put in parentheses to make sure that I take care of this negative correctly. Okay, it's not just going to be 1 minus, or I'm sorry, it's not just going to be minus 1 minus cosine squared. I have to actually distribute that. So it changes the sign on the cosine squared theta, the second one. There we go. So I distribute the negative, and then I combine my like terms. All right, the nice thing about this is if you're trying to solve a problem and you want to get everything to sine or cosine, you can use one of these to get there. The tricky thing about this is you now have 3 possibilities here. So if you're doing a proof, you have 3 possibilities for cosine 2 theta, and you have to decide which one's going to work best for you. See the tan one, well, this is just going to be tan theta plus theta. So that's tan plus tan over 1 minus tan tan. There we go. We just need to simplify. Tan plus tan is going to give us 2 tan, and then tan times tan is going to give us tan squared. Okay, there are our new identities here, 3 of them, but really in the end, 5. So if you were to go use the wrong one here, it would really just make your problem longer, but you could get back to the right one. All right, so let's give this a try then. Use the double angle identities to evaluate the following. So I have the sine of 420. Well, that's the same as the sine of 2 times 210. So the sine one is right here. So I'm just going to go ahead and write 2 cosine. And instead of using the 420, I'm going to use the 210 here. 2 cosine 210 times sine 210. Then you'd want to figure out on your unit circle where 210 is, and it is in this quadrant here, which makes it 30 degrees after 180. So this is 30. So you just have to think about, well, cosine, what's adjacent and what's opposite? Well, these are going to be -1. This is negative square root 3, and this is 2. So I get 2 times cosine, or actually, I had these backwards in my notes. Hold on. Okay, cosine is square root 3 over 2 times 1/2, -1/2. All right, our negatives are going to multiply together and make them positive. And so I have 2 square root 3 all over 2. These can or sorry, all over 4. Ooh, making silly mistakes here. All right, 2 times 2 is 4. These can simplify, and now I have square root 3 over 2. Well, square root 3 over 2 might be familiar to you because this is one of the ratios that's on the unit circle. And it turns out the angle 420, well, 420 is going to be the same as sine 460, right? So, which is right here. And sine 60 is on the unit circle. Okay, they're both on the unit circle, so it turns out using the double angle identity is just another way of getting there, but it's kind of a longer way of getting there because you could just find this right on the unit circle. So let's use it in a different capacity over here to solve this problem. We're still going to look for exact angles, and I should have this in here, but I want the angles from 0, let's include 0, to 2 pi. Okay, so let's get started here. I'm going to take this cosine and move it to the other side and make it cosine theta equals 0. Now I need to decide, okay, well, which one of these cosines should I use? Because I could use any of them. But what I'm thinking is I don't want to add a sine into the mix here. If I can just keep it all cosine, it'll probably be easier to solve this. So I'm going to use this one right here. Okay, so I've subbed this in, and now I'm seeing, well, I have a cosine squared, and I have just a regular cosine, and I have a constant. Well, if I rearrange this, I would have a quadratic. And then I can just use substitution to factor this, or make it a little more easy for me to factor. Okay, so I just took out my cosines, put in u, and then I factored it from here. Now, if you don't know how to factor, that's just a whole other video. So you can come and get help on this, but I wasn't going to show that in this video about how I got to here. So I factored, I got here, then I plugged my cosine back in, and now I just need to use the zero product property to see where each of these would be 0. So I solved both of them. I need to find out where cosine equals -1/2, and that's going to be at 2 pi over 3 and at 4 pi over 3. And I'm not going to go over again in this video on how to find that on my unit circle. If you need help with that, please come see me. And then cosine theta equals 1, well, that is going to be at 0. So I have 3 answers for this one. All right, let's take a look at the back now. Okay, so half angle identities. Well, for these, I'm not going to derive them. When we get into these problems down here, they're going to be complicated enough. So we are just going to, I'm just going to give them to you, and you just need to make sure you write them all down, and then I'll show you how to apply them. Okay, so here they are. You'll notice the sine and the cosine one look awfully a lot alike. One is minus, and one is plus in the middle, and then we have 3 for tangent again. So get all these down. Pause it, and then come back when you're ready. Okay, so why is there the plus or minus symbol? Well, it's not because there are 2 answers, right? Sometimes that means that there's 2 answers. It's because you have to decide what the symbol should be based on the quadrant the angle will be in. Think of all students take calculus. So, sine 67. Well, 67 is going to be in this quadrant. So you need to think about this one, not this one, the original. What is the sign going to be? Well, the sign's going to be positive. Okay, so at the end of this, you need to have a positive answer. So we need to use the sine one. It's right there. And we're just going to, well, if we want to use the half angle, 67.5 is not on the unit circle. But if we double it and then divide by 2, we still have 67.5. But 135 is on the unit circle. I just took my identity from above. I have a subtraction sign here. Notice I did not put the plus or minus. I already determined it's plus, it's positive. So I'm just going to leave it like that. And then you just need to use your strong math skills to deal with radicals and fractions. So I have 1 minus the negative square root 2 over 2. Just found that from my unit circle. And then I'm going to put this as 2 over 2 here. Square root of 2 over 2. Subtracting a negative is going to make it a positive, and we have root 2 over 2 all over 2. I need plenty of room here, so I scrolled down. Then the square root of, well, I add these together, and I cannot add together 2 and root 2, so I'm just going to put them next to each other, over 2, all divided by 2. Okay, so now I need to multiply, so I have a fraction divided by 2. Well, this is the same as 2 over 1. So I need to multiply by the reciprocal. Also, when you divide by 2, that's the same as multiplying by 1/2. So this becomes 2 plus square root 2 all over 4. Now I can't take the square root of the top, but I can take the square root of the bottom. That's just going to be 2. And so my final answer on this is the square root of 2 plus the square root of 2. So square root over this whole thing, all divided by 2. Okay, so this is the exact answer here, and this is what I'm looking for that you can find is the exact answer. But just to prove to you, or just to show you how to check, if I were to find the approximate answer, it would be, and I typed it into my calculator, I got 0.9234. Well, if you were to type this into your calculator, sine of 67.5, you would come up with 0.924, and that's how you know you did the problem correctly. But the actual answer that I'm looking for is your exact answer. That's why we're going through this whole process of using this identity. All right, tangent. Well, tangent 157.5, that is not on the unit circle, but I could use tangent of 315 divided by 2. All right, tangents, these are a fun one. I'm going to go ahead and use, it doesn't matter. You can use any of them. I'm going to use this one at the bottom here. I just randomly picked it and fill in all my parts. So I filled this in, but I forgot to look at this tangent. Well, where at 157, what quadrant is tangent are we going to be? Sorry, we're going to be in the third quadrant for 157, and here tangent is negative, so our answer is going to be negative. Negative answer. Okay, so I put all this in here. Now I need to find out what sine of 315 is and cosine of 315 is. Okay, I put those in. Now I need to simplify. I need to make a common denominator here. I'm going to go ahead and add these together. I'll keep the denominator of 2. And the numerator here is going to be 2 plus root 2 because I can't combine them, and I've done nothing to the top thus far. Okay. I'm showing you as many steps as possible here so that way you guys can follow along and not get lost. So now I'm going to multiply by the reciprocal. And these cancel out. So now I have negative root 2 all over 2 plus the square root 2. Well, we don't really like that radical in the denominator, so we're going to multiply by the conjugate, which would be 2 minus root 2. And that's going to give us, I need plenty of room here, so I'm going to go right back up here. Square root of root 2 times 2 minus root 2 all over, well, this is a difference of squares, so 2 squared minus square root 2 squared. Now let's simplify all this out here. I'm going to handle, well, I'll do both the top and bottom. I'm going to go ahead and distribute this. This would be negative 2 root 2. A negative times a negative is a positive. And then root 2 times root 2 is just going to give me 2. All right, in the denominator, 2 squared is 4. Minus root 2 squared, well, that's 2. Take it another step. I have negative 2 root 2 plus 2. 4 minus 2 is 2. And I can simplify. You need this 2 to be in both of these in order to simplify. So it's going to go into here once and into here once. And I have negative root 2 plus 2. All of this simplified down to this answer, which is the exact answer. Okay, so I'm going to punch this in my calculator to check my work and make sure that I came up with the right answer. So the approximate answer to this, when I type that in my calculator, is negative 0.414. Well, you would have to type this into your calculator and see if that comes up with the same answer. And it does. And also, it should end up to be negative because we already figured out that that's the quadrant that it is in, so it should be negative. All right, thanks for watching, and we will work on this in class.